Welcome back. Let's continue with the wind energy sector. Projections for new installed capacity are incredible. That will require a huge effort from the whole supply chain. Not just because of the need for scaling up the production capacity, but because this will stress the materials management as well. It's clear that the cost of electricity produced, or LCOE, is and will continue to be the main driver. Additionally, the sustainability of the sector is also very relevant. It's not just about producing electricity from a renewable and clean energy source but providing it in the cleanest way. So, materials, its sourcing and how they are disposed once the lifetime of the power plant is over is a very important point. As we discuss in our previous video, one of the technologies that companies should be looking into is recycling. So let's take a look into the materials that are being used. In terms of weight per megawatt, the most relevant are steel and other metals. They represent close to 90% and can be easily recycled. Rare earths and composite materials represent a bigger challenge. The other major waste is the concrete in the foundations. Let's compare main blocks of materials. There are different kind of wind turbines and sizes, so we will analyze it in average. The biggest part is concrete, up to 350 tons per megawatt, what represents 68% of the weight. The second largest element are the metals and alloys, adding another 150 ton per megawatt, representing a 29%. Most of these materials are recycled and recovered for further use. Composite materials account for 13 ton per megawatt or 2.5%. So, if a wind turbine and its foundation is already being recycled up to 90% of its weight, why to bother about blades? There are two clear reasons for taking care of blades. First one is that companies are pushing for becoming greener in front of their stakeholders. The second one is that blades are bulky. So, even if the quantity of composites to recycle is not as relevant when compared with other materials, the visual impact is huge. Moreover, the low degradation over time makes them an environmental issue. The construction of the blade does have some particularities. Two shells are glued to build up the aerodynamic shape. The blade root is reinforced with an extra thickness of composite material and a steel structure that hosts the bolts. Internally, there is a frame structure that provides rigidity to support the flexion and torsion loads. Sometimes is created by two spar caps and two webs, and others by a caisson. Shells, webs and spar caps are made from different plies of glass or carbon fibers fabrics, with different orientations, and embedded in a polymer. This polymer is finally cured. In same areas, some other materials, like balsa wood, are embedded to provide an extra thickness at a low weight. Landfill is the current solution for wind turbine blade disposal. Forecast for wind turbine decommissioning is anticipating that 1.25 terawatts will be dismantled, what translates into more than 3 million blades. Clearly, landfilling is not the solution for wind turbine blades. Whether the blade is to be sent to the landfill, or prepared for any recycling process, it will be cut down in smaller pieces. Blades are designed to last, so cutting them is not so easy. Different methods will be used. Sawing, diamond wire cutting, or waterjet cutting are the most common methods. To dispose the composite materials, we have several alternatives to the landfill. Some of them will allow to recover some of the raw material, and so, to use it back into the manufacturing process. This will be a preferred solution providing technology and pricing allows it. So, landfill pricing will play a role as well. Burning the material in high-temp ovens is an easy solution. Companies have explored how to cooperate with the cement industry. Major hurdles to overcome are cadency of supply and potential pollutants that may affect the quality of the cement. Mechanical grinding is a straightforward solution. The outcome is being used as a filler in the construction sector. Main hurdles for this process are the heterogeneity of the output and cost efficiency of the process. On the positive side, high throughput can be achieved. Gasification is a very well-known process that may be a very good alternative for composites disposal. but is not coming for free. Volumes and cadency are critical to make an efficient process, so will have to be combined with other waste sources to make it viable. As two previous solutions, raw material cannot be recovered, so it must be considered as a waste disposal solution rather than a recycling for reuse one. Only the last three technologies, high-energy plasma, solvolysis and pyrolysis, do have the potential to recover the raw material. This will allow for a fully circular use of the raw materials and so real recyclable solutions. All three of them are in the development phase and hopefully will become fully commercial very soon. We will have specific videos for them to deep dive into the technologies behind. Hope you have enjoyed this video and thanks for watching.